You see the pattern yet? And I see the pattern. I mean, it's just, again, graph it, give me a max, give me a min, find the D value, find the A value, find the C value, find the B value, you're done. Well, then shut up and let's go. Okay. It says a spring. The physics guys are going to love me for this. A spring modeling a sinusoidal function rests at 1.6 meters above the ground. Okay, so look, you got a spring. It's probably attached to something up here. There's your spring. Okay, it's going to rest at 1.6 meters above the ground. Huh, gee, I wonder if that's our D value. Yeah, no kidding, because that's going to be our center line all the way through this. Sweet. Okay, now you're going to put a mass on the spring. Okay, so obviously this spring goes to church. Mass, get it? Yeah. Okay, anyways. All right, so you're going to put a mass on this, and then this thing is going to pull it down 1.1 meters. So it's pulled 1.1 meters below its resting point. So guess what? You just figured out the amplitude. This is going to be pulled down then, if you think about this, this is going to be pulled down to what? Well, yeah, it's going to be pulled down to 0.5 meters because you're pulling it down 1.1 meters. So 1.6 minus 1.1 gives you 0.5 left. So there's your low point. And this is going to bounce back up like this to its high point, which, like it says here, neglecting friction and air resistance, okay? So this is going to bounce up to, yep, 2.7 meters. There you go. There's your everything that you need. Now, the other thing that you need here is it says, look, it says it takes 0.5 seconds to move from the maximum to its minimum position each time. Gee, I wonder if we can figure out the period for this. Yeah, okay. So think about it. It goes from its bottom, check this out. It goes from the bottom to the top, and it does that in 0.5 seconds. Oh, so what happens if it goes back down to the bottom? So if this is 0.5 seconds, this then is 0.5 seconds. To do the whole thing takes you a period, oh my goodness, you can't be serious, of 1 second. Oh, how lovely. Oh, look at all this. I haven't even finished reading the question. It says graph the height of the mass above the ground as a function of time for the first 2 seconds. Oh, okay. So there's your period of 1 second, and just go out and write it out again. There it is, 2 seconds. There's your first graph. Okay, now it says write an equation of the sinusoidal function in terms of sine. Oh, man. Oh, man. Okay, real easy. Really, really easy to do. Let me show you how. Okay, first things first, let's start finding some values. Let's find the A value, which you know is the maximum, right? Minus the minimum, right? All over 2. So the max minus the min all over 2 works out to be, oh, look at this, works out to be 1.1. Throw that in your calculator, okay? So 2.7 minus 0.5 is 2.2, divided by 2 is 1.1, yippee skippy. The D value, okay, well, we know the D value. The D value, no, is in the middle here. That's 1.6. That's the resting position. Don't believe me? Watch. 2.7 plus 0.5 over 2. 2.7 plus 0.5 is 3.2. Divided by 2 is going to give you 1.6. Oh, my goodness. I knew that. Let's figure out the B. The B value is 2 pi over the period. Oh, my. That's going to... Oh, come on. Really? Yep. It's going to be that easy. But now we got to figure out the C value because it says write an equation of the sinusoidal function in terms of sine. Okay, so remember what we're trying to do here. We're going from here up to its maximum, down to its minimum, and back to normal here. So we have to figure out what that shift was. Okay, so let's start being smart. You know you went from its lowest point to its highest point in exactly 0.5 seconds. So notice that that's smack dab in the middle. If that's smack dab in the middle, guess what? That's at 0.25 seconds. Think about it. It took 0.25 seconds to get to here, another 0.25 seconds to get to the top. So there, folks, is your C value. So you shifted this guy out to the right, 0.25 seconds. Now we can write the proper sine function. Okay, y equals to a, your a value, 1.1. Sine, your period, 2 pi, your b value, 2 pi. Bracket, x, you shifted 0.25 to the right. So, we want this in terms of time. So I'm going to put it as time. And I'm going to have to change this guy too, because you can't have a y. You got to have the height as a function of time. Oh boy, I've never seen that before. T, shifting to the right, minus 0.25. There it is, plus your d value, which you remembered, and we calculated out here to be 1.6. Oh, what a riot. Okay, so do you notice that all of these questions usually ask the same basic things over and over and over again? Look at this. It says estimate the height to the nearest tenth of a meter of the spring above the ground in 2.3 seconds. Height as a function of 2.3 seconds. Throw it in there. 1.1 sine 2 pi. The time now, this guy here, is 2.3 minus 0.25 bracket plus 1.6. Just throw it exactly how you see it on the screen there right into your calculator. Okay, let's do that. Let's bring up our calculator and start punching it in. 1.1 sine. Don't forget, you got your 2 pi there. So second, oh, wait, hold it. We don't want a second yet. We want our 2 in there first. Then pi. Ah, got it. Okay. Bracket. There's your x. Now, wait, what was your x? At what time was it? Hold it. My time here was at 2.3 seconds. Oh, okay. So let's put in 2.3, not x. Okay. Minus the 0.25, which was the shift. Okay. There's that bracket. Don't forget your other bracket here, because think about it. Look, you got a bracket here, but you also have a bracket here that you have to finish it off. All right. Okay. Plus the 1.6. That should give you a very nice value. Enter. Oh, come on, you. There it goes. Of 1.93. Now, 1.939, and it says here to the nearest tenth, 1.9, and this would be meters. Beautiful. Now, same thing goes with this. Estimate one of the times when it's 2 meters off the ground. Okay, so remember, that's your height now. Okay, so it's 2 meters. There's the 1.1 sine 2 pi. There's your time that you're trying to figure out. There's your 0.25 shift plus your d value. Okay, do a little bit of algebra on this guy, right? Subtract out the 1.6, subtract out the 1.6, leaving you, yep, you got it. Look how this is really nice. It's just turning out beautifully. 0.4 equals to 1.1 sine of 2 pi. There's the t. I'm going to revert it back down to an x again. And the reason why I'm reverting it back down to the x is because that's how I'm going to put it in the calculator. Okay? I'm going to divide by my 1.1, which works out to be really ugly. Okay? There's my y1. There's my y2. And I'm going to throw it in my calculator. Okay, let's do that. So I spared you the agony and just put it in there for you. Okay? Then, don't forget, zoom, trig, but make sure you're on radians, which is right here. That's the important part. Has to be in radians. Zoom trig 7, and you should get a very nice value coming up. Oh my goodness, look at that. And it says, estimate one of the times. Well, look for this intersection, which looks like it's about right there. Okay, so find that intersection. Second calc, find me the intersect, 5, and mouse it close to there. Well, that looks pretty close. I'm going to try to get almost on top of that there. Perfect, perfect. I'm going to get at 0.309 seconds. 0.309 seconds, which means, oh, look, to the nearest 100, 0.309 is 0.31 seconds, and that's how you solve those kinds of questions.